The topic is base conversion. We will learn about base conversion functions. In the previous lecture, I have explained about literals. We learned that we can represent literals using different number systems like binary number system, octal system, and also using hexadecimal number system, right? There I told you that if you know about number system, if you are familiar, then you can use those number systems for representing any integer type literal. But now we have the functions like binary, oct, bin for binary, and oct for octal, and hex for hexa. What these functions are, we will learn about them. These functions are useful for converting any integer value into a number system. So it will convert an integer value from decimal to a other number system. So it means it will change the base. So that's why these functions are called as base conversion functions. For example, I have the variables here. I have variable a whose value is 10. You want to know what will be the binary form of this 10. This is in decimal number system, right? This is in decimal. What is the binary form of this 10? So you can call this function binary upon this a. So it will give you a binary form of a, and that will be stored in x. Similarly, you can find out what is the octal form of any of these integer value, and also you can find out what is the hexadecimal form of a decimal value. So these functions will convert the base of a decimal number or integral value in the decimal form. And one important thing, all these functions gives string result. So what will be the value inside this variable x? This variable x will be holding the binary form of this a. A is 10. So the binary form of a is 1010, and this is in quotes because this is a string. All these functions return string. Just you want to know how the binary form or octal form looks like, you can use this function. So it gives you a string form of binary number or octal or hexadecimal number. Same way I can say oct of a. So it will give the octal form of this value 10. So the octal of 10 is 0012. So 10 is 12 in octal form. If I convert this into hexa, so the base conversion of a value 10 in hexadecimal form will be 0x and letter a. So it will use small a, but it will be a string. So all these I am showing you that they are in the form of a string. That's it. So these functions are for converting a decimal number into another number system. So what is the use of this one? Suppose you want to know what is the binary equivalent of any value like 16. If you want to know what is the binary equivalent of 16, you can call this function upon b. So if you say y assign binary form of value b, that is 16, so you will get the result. So 16 is 0b1 4 times zeros. This is the binary form of 16. So you will get this answer, right? So these functions will help you convert a decimal to any other number system, but they give string form. That's all. Alright, just I will give you a quick demo and you can practice the same thing. Here I will take the value a as 10 and b as 16, c as 255. Now I will just write binary of a, so it will print the value directly. So yes, this is the binary form of a. Binary form of b, so this is 1 4 times zeros. Binary form of c, that is 255. C is 255, so you will find that it will be 8 times 1. Yes, this is 8 times 1. 0b 1111 1111, right? So if I want to know octal form, so OCT of a, so will give you 12, and octal of 16 gives you 20, 20. Don't read it as 20, just read it as 20. Octal form of that is 255. C is 255, so directly I am giving the value 255. So that is 377. Alright. Hexadecimal of 10 is A, hexa of 16 is 10, and hexa of 255 is double F. That's it. Now, will it work hexa of true? Will it work on binary? Sorry, Boolean type? Yes, it works on Boolean type. It is giving the value as 1. And binary of true? Yes, it is working. Let me restart this ideally. So now I got a clear window once again. Now let us check. I want to convert the number into binary, base as binary, and the number is 12.5. It doesn't work. So you read the error message. See, whenever you are getting error messages, try to read them. You should understand error messages also. So that will help you avoid any errors. You should be knowing what type of error you get. See, the error is float object cannot be interpreted as integer. So it means this binary function bin requires a integer value only, right? So if I want to convert binary and the number is 10 plus 0j, let us check what happens. Yeah, error is complex object cannot be interpreted as integer. So this is the error, and it is showing that this function is causing an error. So complex object cannot be interpreted as integer. So only which type of values are allowed? Only int type and bool type of values are allowed in these functions. All right. So that's all about these functions. That's all in this lecture. Just check these things by yourself once in Ideally.